So once again, we see our first office holding is pretty much over by mid-1585. What does that tell me? It tells me that our office holders, the ones that we have data for, pretty much all have some kind of, I'm not really sure about this guy being born in 1585. He was maybe an 18-year-old in 1601 or something. But you can see that most of these office holders, if you look at year of first office, are clustered. And that makes very good sense, because we begin to see that probably their first office is a military one, when we start to look at that pattern. Anything before 1585, I start to look at and think, it's probably not a military first office. So again, we can segment the data that way. And so these again are just sort of diagnostic about how to put the data together. That's you, Mike.
Yes, that's me. So the second thing we started to look at was, as Bill has indicated, we have lots of offices for individuals. Individuals often have many offices. Some have 20, 30 offices that they've held. So one of the things I started to do was to look at pairs of offices. So you could look at, this person was a captain, and then the next office that they had was as a general. Okay? And so that's a pair to me. So what you can do out of the database is you can extract all the offices, and then I can actually go through and for each individual generate a set of pairs. This was their first office, this was their second office. This was their second office, this was the third office. Third office, fourth office. So you count all the pairs. Okay? And what that gives you, it gives you a sense of a transition. Okay? It gives you a sense of they were in a captain's position and then they moved on to a general's position or some other kind of position, whether it be military or civilian. So basically it gives you an ordering of the offices that individuals went through. So one of the things you can do is you can capture all of those pairs. And so I've got software that does that. Then what you can do is you can count each of those pairs. So every pair that's Captain General, I simply count. And it gives me a measure of the frequency of which individuals would actually go from captain to general. And we can count all those. And in general, out of this entire data set, there's roughly about 800 different pairs that one can count. Well, you count all the pairs, you have all the number, oh, I'm sorry, there's 3,000 plus pairs, 800 distinct ones. So you can go through and you can count all the pairs, you can build a frequency of a pair occurring, and then you can go back and simply compute the probability. What's the probability of going from a captain to a general, given that you've counted all these things, and given that you've got the office information for all of the individuals. So what this allows you to do is to construct something called a Markov graph. And basically what a Markov graph does is basically it's a representation of being in one state and what's the probability of moving to another state. And then you can begin to combine these, and what it does is it gives you sort of a probabilistic view of transitions, the likelihood of going from one state to another. It also is a way of looking at those states which have high occurring values, because it means either they're important or they're the kinds of things that were relished by individuals, or they just happen to be frequent. So what we started to do was to build a Markov graph. So to give you an idea, and again, there's lots and lots of these, and recall that there's lots of different kinds of pairs. There's over 800 different kinds of pairs. So to give you some examples, if you were a captain and you made a transition to a captain of horse, that actually occurs just about 1% of the time. Okay, so again, you have to look at these in terms of relativistic numbers. Going from a captain of foot to a captain, and Bill can explain what these positions are. Captain of foot occurs about just about 2% of the time. Captain to a captain occurs about 3.4% of the time. So basically, somebody was a captain, then re-enlists or gets rehired as a captain. Okay, so there's a repetition there. And then captain to death is actually not an office. That's just right at the end. Well, I suppose it would be a permanent office. But, so in this case, if you're a captain, the last office you held was as a captain, at least based upon the information that's in the database. So you can look at the transitions and you can look at pulling these things together. Now, we haven't actually looked at displaying the entire graph because it would have 800 nodes in it. So what we did was we extracted the data from graph where you looked at edges, or you looked at these transitions that had a certain cutoff probability. So when you do that, you actually get something like this. It's one of the things we've started to do is use this data to actually start to build some visualization tools. So this was the other idea that I had. How do you look at a graph that's got 800 nodes? You need some mechanism other than just displaying this. So this is actually, unfortunately you can't demo this, but this is actually an interactive tool I have a student working on this summer. And they take the data and they construct these graphs automatically. The program reads it in, constructs the graph, and then you have this interactive tool where somebody like Bill can sit down and move these things around. So this is one set of data that's been extracted. And actually, maybe if I...
There are 29 pairs on that, aren't there?
Yeah, there's 29 pairs on this. And you notice it's not complete because I've only got an extracted subset out of the whole graph. In fact, if I had everything connected, if I had all the data, it would be connected. So you can see there's this little one down here. The edges represent different the edges are different colors, and they represent different levels of probability. Okay, so I think the red ones are higher, and the blue ones are even higher, and so forth. This actually represents this node in the middle here that's been highlighted. So the way this interactive tool works, the way the tool works is you can manipulate these things. You can pull the nodes around. You can reposition them. And this is one positioning where it's actually possible to see everything. And then you can actually click on a node and you get information. And you can't read this, but this basically gives you the title or what this node represents. It represents a captain, and then the associated information is there. So the idea is eventually to build a tool to allow Bill, in this case, to be able to go through and begin to manipulate this and look for unusual patterns or commonalities and so forth. I don't know if you want to comment on this or the next one.